Our next video in the series of videos is going to talk about the arithmetic series. Now, an arithmetic series is a sum of the terms in an arithmetic sequence. So these terms, -7, -2, 3, 8, and so on, all the way up to 503, make up an arithmetic sequence. If they were to separate it by commas, you would say that U1, the first term, is -7. And then you would use that formula to calculate D. You would say that, well, D is equal to, let's take the second term and minus the first term. So that's going to be -2 minus -7. And that's going to be equal to 5. Now, you probably didn't need to show all of this work to find D. I'm fairly certain you could have just seen that the pattern was it's going up by 5. Now, to find the sum of the terms in an arithmetic sequence, we need a formula. Now, the development of that formula is a commonly told math story about Friedrich Gauss. I think it might have been Carl Friedrich Gauss. I'm not really sure what his full name is. He's the one that the math contest from the University of Waterloo is named after, though. Story goes, he was a very large pain in the butt in class, and so his teacher just challenged him by saying, okay, quick, add all the numbers up from 1 to 10,000. To which Gauss turned around and said, okay, that's 50,050,000. And I don't know if I'm 100% right on that because I'm not as fast as Gauss, but there was a trick that he did. Essentially, he said, okay, well, if I take the first number and the last number and I add them together, and I take the second number and the second last number, which would be 498, and I add them together, I'm going to get the same thing each time. So let's just take a look at that. Let's take the last term, 503, and we'll add -7. So what do we get from that? Well, it seems like what we get is we get 496. And then let's take the second last term, 498, and we'll add the second term, plus -2, and we get 496. And I don't think you'd be shocked that if I just continued doing this, taking each term as I moved along in toward the middle and adding them up, I would get to 496 no matter what. Because to get from this term to this term, you're adding 5. To get from this term to this term, you're subtracting 5. And it doesn't matter whether it's 5 or some other common difference, you're still adding the difference and subtracting the difference each time. And so you're really doing nothing to it at all. So essentially the question then just becomes, okay, well, how many pairs can I make? Then I just have to multiply that number of pairs times this sum. Well, that results in a formula. And that's the sum of the n terms in a sequence. Now that means adding up all of the terms. So you'd have to know how many there are. Now, the way that we do that is we say, okay, well, let's take the first term, U1, and let's add to it the last term, UN, because that would be the nth term, and then we'll multiply by however many pairs I can make. Now, if you want to find out how many pairs you can make of something, just take your total number and divide it by 2. So that results in the formula for the sum of an arithmetic series. Now, we can change UN slightly, and if you've watched the video on arithmetic sequences already, you'll recognize what I'm doing. All I'm doing is replacing UN with the general term. So this simplifies just a little bit further. N over 2, 2U1, so twice the first term, plus D and -1. And so this is an alternate form of the same formula. And you'll find this formula for the sum of the n terms of an arithmetic series in your formula book. Now, if we wanted to apply this to our example, what we'd have to do is we'd have to figure out, okay, well, what value is 503 for n? So we know UN is equal to -7 plus 5 and -1. We'll substitute in 503. So that's equal to -7 plus 5 and -1. Adding 7 to both sides gives us 510. Dividing by 5 from both sides gives us 102. And adding 1 to both sides gives us 103. So there's 103 terms here. but wait a second, if I have 103 terms, how can I have pairs? Because it's going to leave me with an odd number. But that's actually okay, because then when you add the first and last numbers, you're going to create an even number. And an odd number divided by 2 is going to leave you with a decimal, 0.5. And multiplying that by an even number is going to change that to a whole number again. So we'll be back to a good set of numbers to use. So now we can apply this formula. We can find the sum of the 103 terms to add up all of these numbers. And this is how it's denoted, sum 103. If you had S10, that would be the sum of the first 10 terms. But here we have S103. So this is 103 over 2 times 2 times the first term, -7, plus D, 5, times 103 minus 1. Well, it looks bad, but it actually isn't that bad. I'm going to leave this as 103 over 2 because I'm hoping something's going to happen. This is going to be -14. This is 5 times 102, which we've done up here already. So this is plus 510. And I think that you're quickly going to see that this plus this is going to give me 496, which is exactly what Gauss was doing. So I'll have 103 over 2 times 496. Good, the 2's cancel out, so the 2 will divide into 496, leaving 248. So I have 103 times 248, which, I don't really know that off the top of my head, so I'm gonna, well, it's just gonna do 248 times 3. And I'm going to then add 100, because I'll do 100 times 248. And so this will give me 4, 4, 5, 5, 2. So 25,544. And that is the sum of the 103 terms for this particular series.